So good afternoon to all of you. So if you remember what we have done in the class, we have done the rounding error, that the error can maximum have, if I am using the rounding error, the absolute error can be maximum of half into 10 raised to the power e minus n. And we have done that for the relative error, the maximum error can be half into 10 raised to the power 1 minus n, that we have done the proof, right? Then I have told you about the significant digits and decimal places. So what was the difference between your significant digits and your n decimal places was that if it is given n decimal places, that means you can trust the digits after the decimal. But if it is given to you n significant digits, that means you can trust total of n digits. So we have done example for that. If my number is 46.31, right? And we have, it is correct up to only 2 decimal places, right? That we have done because there are 2 places after the decimal. But if we want 2 significant digits, what it will be? Only the total. There are now, if you convert this into the number floating point representation, so if you want only 2 significant digits, that means you can have only the number of digits will be 2. So in that case, your number is 46 in that case of significant digits. But if I am talking about the number is that you have to consider correct up to 2 decimal places, then you can consider after decimal places 2 digits, right? Then now that is the definition of the significant digits. Next is, since we are using the approximating a number, like I have a number x that we have done example. If I have a number x, that is my, suppose that is my number 2, right? And suppose these two are the approximations. X1 and X2 are both the approximation of 2, that I am considering 1.9999, right? And the next I am considering 2.9999. So now you know that which approximation is close to 2? 1.999, because when you will round it off, that will give you this number, right? So how do you say up? Now the question is that how many digits, significant digits, x1 star have, so that it is a close approximation of x. Am I clear? कि x1 स्टार में x की कितनी सिग्निफिकेंट डिजिट्स हैं, राइट? अब वैसे तो x में आपका 2 है, ठीक है, यहाँ पे आपका 2 यहाँ पे प्रेजेंट है, बट स्टिल आप इसको सिग्निफिकेंट डिजिट्स आप नहीं बोल रहे हो, क्योंकि क्यों ही आपकी क्लोज अप्रोक्सीमेशन नहीं है? बिकॉज ऑफ दिस, व्हेन यू विल कैलकुलेट द रिलेटिव एरर, आप क्या कहोगे कि नंबर x की x स्टार में कितनी सिग्निफिकेंट डिजिट्स हैं? इफ यू सेटिस्फाई दिस प्रॉपर्टी, राइट? When you will have x minus x star by mod x, that will be less than half into 10 raised to the power 1 minus m. तब आप क्या कहोगे कि I have m significant digits, that my approximation has m significant digits corresponding to my actual number. Am I clear? Yes or no? I am repeating that if you have any number x and if you have any number x star, तो आपकी x स्टार में कितनी टोटल सिग्निफिकेंट डिजिट्स हैं x के रिलेटिव में, ठीक है? अब ऐसे तो सिग्निफिकेंट डिजिट्स की मैं बात करूं, इसमें भी मेरे कितने सिग्निफिकेंट डिजिट्स हैं? आई हैव 5 सिग्निफिकेंट डिजिट्स, बट दैट 5 सिग्निफिकेंट डिजिट्स आर नॉट रिलेटेड टू x, राइट? Am I clear what I am saying? Still it has 5 significant digits, but it is not significant digits related to my actual number, right? So here you can see from here that 1.999, right? This you are saying a close approximation, and then that means it does not have any similar digits, but it has 5 significant digits corresponding to your actual number, you can also show it by from this expression also, right? So matching of the criteria is not कि आपके significant digits उसमें हैं. You can check over here कि यहाँ पे 2 मैच तो यहाँ पे हो रहा है, but ये आपके significant digits नहीं है corresponding to your actual number. Is it clear? Total significant digits कहें या हम कहें significant digits of a actual number, is the difference clear? Good morning. Is the difference clear? When you wake up, then it is morning. Is it clear? Yes or no? For example, if you consider any number, I am considering x is equal to √2 and I am considering the approximation 1.414. Now I want to know how many significant digit it has. Now we will use this definition. आपने सीधा ही देख के नहीं बोल देना कि that has 5 digits. ठीक है, ऐसे तो मैं इसको नंबर 2.414 भी लिख सकती हूँ, that you can say this is my 4 digits you have common. But no, you can't say, because total number of significant digit is no doubt here is 4. But how much significant digit x star has corresponding to your under √2? Is it clear? So how you will check? We will calculate the relative error, ER, that will be your x minus x star by x. Then you will do √2, and if you take more approximation 1.4142 and so on, if you consider the 16 digits even, then you subtract 1.414, divide by your 1.4142, and if you consider the 16 digits, this is coming out to be your 0.0002, right? अब आपने डेफिनेशन यूज करनी है दैट इट शुड बी लेस देन इक्वल टू 0.5 into 10 raised to the power 1 minus m, और m जो है आपका वो सबसे लार्जेस्ट होना चाहिए. कैन आई राइट दिस थिंग एज दैट दिस इज माय 0.2 into 10 raised to the power -3? Yes or no? Clear? So this is 0.2 into 10 raised to the power 1 minus 4. Can I write? Yes or no? वैसे तो आप इसको 0.02 भी लिख सकते थे और 10 raised to the power -2 कर देते. That can also be the option. तब भी वो आपका 0.5 से छोटा ही रहता. But the definition says that this m should be the largest positive integer. से छोटे इंटीजर हो सकते हैं, but this is the largest positive integer that will tell you the number of significant digit it has. Is it clear? Yes or no? So now here the value of your m is 4. That means 1.414 has 4 significant digits corresponding to under √x, under √2, right? I have not done the calculation that you can do. Relative error आप इसके लिए निकालो, that you calculate 1.4142 and something, minus if you do 2.414 and calculate 1.4142, then you are unable to find the integer that will be less than, that will be coming out to be your so √2 minus 1.414, if I am considering, it is giving me answer as 0.5431, so on, right? So can you write it in the terms? Can you write like this? That will be less than 10 raised to the power minus, that will be your 1 minus m. So you can write this is less than equal to 0.5 into 10 raised to the power. Here because there is nothing, that means this is into 10 raised to the power 0. So that you can write 1 minus 1. Sorry. So then you are unable, now this is number is not less than 0.5, right? So you can't write, however it is 10 raised to the power 0 over here, that you can write 1 minus 1, but this number is not less than 0.5. That's why you are saying that it is not my close approximation, right? That's why you are saying that since 2.414 has 0 significant digits corresponding to root 2, इसीलिए ही आप root 2 की approximation 2.414 नहीं, आप 1.414 लेते हो. Am I clear? Yes or no? Now you understand the difference? Significant digits total में और significant digits वो correspondingly number के कितने ले रहा है, that depends on your relative error, that if your relative error is coming out to be less than half into 10 raised to the power 1 minus m, and m is the largest positive integer, right? After that, that is the maximum. That can be the other integers can exist, but that will be lower than your m, but m should be the positive largest integer. Is it clear? So one thing more that can be your quiz part, I don't know, but what will be in your quiz, right? So you have done that. ER आपने significant digits के लिए भी यही बोला कि half into 10 raised to the power 1 minus m बोलो या 1 minus n बोलो, and significant digits. So when you are talking about significant digit या आप rounding बोल रहे हो, तो दोनों में ही same है, तो n का मतलब same है. So when you are doing the rounding part, right, then n is the n digits of rounding, right, that you can use, that you can consider n digit rounding, right? But here n means, when you are talking about significant digits, here n is telling you the significant digit a number, or approximate number has for your exact value. Is the difference clear? In the rounding, n denotes that it has, you have to take n digits after rounding, and here n denotes the significant digits that you have to take after for doing your approximation. Is it clear? Yes or no? Now, since we are talking about error, what can be the sources of error? That I'll just tell, there can be many sources of errors. So what can be the foremost? कि आपको पहले किसी ने आपको मॉडल दिया, उसी में ही एरर था. That is inherent error. That when somebody has given you problem, there was already error in that problem, right? So inherent error can be there. Then you can have mathematical modeling error. Mathematical modeling error means when you have some data, right? आपने उसका mathematical model किया, ठीक है? आपने कुछ उसके points छोड़ दिए, ठीक है? जो आप कह रहे थे कि आपको अपना system start करना है 0 से, but वो negative के लिए भी run कर रहा था. That means you have made a model that has some error. Next, what can be the next? When you have to store a number in a computer, what you will have? The rounding or chopping error. Right? Next, other can be truncation error. Truncation error is like you have a series of e raised to the power x. क्या होती है series e raised to the power x की? That you say 1 plus x square by 2 factorial up to so on. And this is never ending series, right? When you have to store a value, you have to truncate that series up to some point. That means there can be some truncation error, and there can be lot of errors that can exist while doing some problem, right? There can be many errors. Is it clear? So these are the sources that you can read from book. In the definition that I have told you, what is inherent error? mathematical modeling error, rounding, truncation, and many. There can be so many errors, right? Like you are dealing with the real numbers, but your system is so sensitive. जैसे artificial intelligence, फिर आप क्या use कर लेते हो? Fuzzy number use कर लेते हैं, ठीक है? But fuzzy number when they use to solve that, they again do some ranking to convert that number into some real part so that they can do the analysis, right? तब उसमें error आ जाता है. So there can be so many errors after when you have modeled your equations. Is it clear? Yes or no? Yes or no? So next is loss of significant digits. Next topic is your loss of significant digits. So consider some function. Consider a function f of x that I am taking root of x plus 1 minus root x, and you have to use 6-digit arithmetic to approximate value of f of x, right? So since square root, you know that it has more than that is your truncation. There will be some truncated number that you can truncate. So only you have to use only 6-digit arithmetic. That means when you will do x plus 1, there should be only 6 digits, right? When you do the under root, you can truncate it only to your 6 digits. When you do this x, then you do the rounding. If it is mentioned 6-digit arithmetic, that means it is rounding, right? Throughout the course, unless and until it is not mentioned that it is chopping, you have to do rounding always, right? So I'll show you example from here, that here if I take x and this is your f of x actual, and here I am taking approximated one, right? So here you have a function root of x plus 1 minus root of x. So if you will consider x as 1, if you evaluate root 1 plus 1 minus of root 1, that will coming out to be your 0.4142137. And when you will evaluate this, now you have to do the approximation will be 6 digit. जब आप √2 निकालोगे माइनस √1, √2 में भी आपको क्या डिजिट्स लेने हैं? 6 डिजिट्स. √1 में भी आपको कितने डिजिट्स लेने हैं? 1 digit. It has only 6 digits, means 0.100. That can be the number, right? So when you have this number, you will have 0.4142, right? When you will do the subtraction, 41421 you can take, right? 0.41421. अब आपकी you can see from here, when you have written this number, इसमें कितने significant digits हैं? 1, 2, 3, 4, 5, 6, 7. There you have 7 significant digits. और आपने सिर्फ 1 के लिए इवेल्युएट किया, आपके पास टोटल सिग्निफिकेंट डिजिट्स कितनी रहेगी? 5. That means you have lost your 1 significant digit. अभी आपने एक ही ऑपरेशन लगाया था and x is just 1, and you have used 6-digit arithmetic operation, you have lost your 1 digit, right? The same if you consider x as 100. So when you will evaluate, this is 100 √1, that will be your 10.04987561 minus root of 100, that will be your 10. And here you will have digits is equal to approximated, even this is 0.49, 0.04987561. 211, right? And here if you use the 6-digit rounding, इसकी भी आपको 6-digit rounding करनी पड़ेगी. That means you can consider only 6 digits in total. So when you will do the rounding, what you will have 10.049. Rounding means, is it clear? Because there you have 8 on your 7th place. So when the rounded off, 7 in this place. So when it will be rounded off, it will add 1 to this place. So this you have, this again, this when you will do, this is the exact number. So you can see from here, this is your 0.0. And now, how many digits you have total over here? Now you have only total 3 significant digits. Here you have only 1, 2, 3, 5 digits. And here you have 3 significant digits. Can you analyze the difference? कि जैसे ही आप ऑपरेशंस लगा रहे हो एंड व्हेन यू आर इंक्रीजिंग x, आप उतने ही डिजिट्स लॉस करते जा रहे हो. दैट मीन्स अगर x आपका 1 लाख है, you can see if x is your 1 lakh, and if you evaluate it, this is coming out to be your 0.0015811,349. And when you approximate a number, because this is coming out to be your 316.2293471 and so on, minus this is 316.22776, and you when you will round it off, you will get this is as 0.001. So you can analyze here कि when you have increased the number, x आपने जब बहुत बड़ा नंबर ले लिया, तब आपके पास सिर्फ एक ही significant digit रह गया. Is it clear? That means when you are doing arithmetic operation, you are using the rounding arithmetic operation, you are losing your significant digits, right? What can be the reasons to lose your significant digits? Reasons for losing significant digits. One is the form of the function fx. The form of function f of x. Next is that what you are using, that you have used 6-digit precision that you have used in this case, or any digit precision, but if you have any number. So how you can say that your significant digit should not lose, right? So this we can't solve because a computer has a limited space that can store. So इसको तो हम solve नहीं कर सकते, that we can't increase the space if we have a computer. But this can be done by us, that we can change the form of a function f of x so that our significant digit should not be lost, right? So what we will do in this case, f of x, like you have root of x plus 1 minus root of x. You have studied in your junior classes that you can factorize this number as x plus 1. You can multiply minus root x, you change the sign. इसको आप क्या बोलते हो? Rationalize, right? So when you will do this thing, here you will have a plus b and here a minus b. Do you have square? So you will have x plus 1, right? Because root square minus root x square, that is your a square minus b square, root x plus 1 minus of plus of root x. So it will be your x plus 1 minus x, and that is your root of x plus 1 plus root of x. Then you have a function 1 by root of x plus 1 plus root x. अब 6-digit precision use करो and choose the value x as 1 lakh. Then you can see if you will evaluate f of x at this point, this will be your 316.229 plus 316.228, and this you will get 0.00158. Now there you have, कितने digits थी आपके पास? Significant, जब we have done, we have only one significant digit, and this is also a close approximation towards your actual approximation, and it has more digits. यहाँ पे कितने significant digits हैं? So here you have 3 significant digits. So just you have changed the form of the function and you have saved your significant digits. So that can be done, because why this is happening in the previous case, when you have the subtraction of two nearly equal numbers, in that case you will lose your digits unless and until you change the form of the function. Like if you have any number x, suppose x is my number 0.123456789, right? And the other number is 0.123456780. Now these are two nearly equal numbers, and when you will do its subtraction, you will lose your significant digits. In that case, you will have only one significant digit. That means you can change the function so that you can avoid the subtraction of nearly equal numbers. So in this way, you can reform your function f of x. Is it clear that how you can save your significant digits just by changing the form of the function? Yes, clear to all? Yes or no? Even you can write one remark or like this. Even if you have number, if x and y are numbers and flx, fly be the floating point representation, be the floating point representation of x and y respectively, then if you are writing x number, suppose this is your number flx 0.alpha1 alpha2 alpha p and it has total k digits, and this is any number 0.alpha1 alpha2 alpha p, and the digits after this are changing. So when you will do its subtraction, now x and y, you can see they have p digits in common, right? So at most, what will be your significant digits in that case? The significant digits you will have, if you will convert it, this will be 0, 0, 0, 0 up to p, it will be 0. And this will be alpha p plus 1. And this is alpha p plus 1. Suppose I am denoting it by gamma, where your gamma is nothing, but this is the subtraction of. So you can see when you write it in the standard normal form of FLP, this is gamma p plus 1, gamma p plus 2. This is your gamma k. So you will have 10 raised to the power e minus p digits will be your significant digits, right? k minus p significant digits. So this is just the definition when you do the subtraction of two nearly equal numbers, and if they have p digits common, and this e also you can replace by your n because you are dealing with the n digit number. So there you can also have n minus p. So it can have at most k minus p significant digit. Is it clear? Now, since you have lose your significant digits, that can also result कि आप accuracy भी lose कर दो, right? That is the next part, that is loss of accuracy. When you lose your significant digits, you can lose your accuracy as well. We will start with this example like that we have done. Suppose if you have any example that you have to use 4-digit arithmetic for calculation or for calculation. To find the roots of and it is given that using MATLAB the roots are given as x1 is minus 0.0011490 and 7561 so on, and x2 is your minus 10.9868748764, right? So you have to use 4-digit rounding arithmetic, right, to approximate to find the approximate roots of the equation, right? And you have equation as that is 1.002x square plus 11.01x plus 0.01265 equal to 0. Now you know all this is your quadratic equation, which you know that are very easy to solve. The roots of that is x1, 2. I am writing. How do you find the root? That is equal to minus b plus minus root of b square minus 4ac by 2a, where this is indicating your a, this is indicating your b, and this is indicating your c. So if you will evaluate using this operation, now you have x12, that is coming out to be your minus b. Here b is your, yes, b is, we are calculating this value using only 4-digit rounding arithmetic. This is my b, minus 11.01 plus minus b square minus 11.01 square minus 4 into AC. A is your 1.002 and this is your 0.01265. And A is your 1.002. Is it clear? सिर्फ आपको 4 digits ही rounding use करनी है. You can see in this first expression सारी digits आपकी 4 digits हैं total. When you convert it into your standard floating point representation, you have all 4 significant digits, right? So since we have to use the rounding, that means we have to do rounding at every step. That means when the square of minus 11.01 will be calculated, the number should be rounded off to your 4 digit. ऐसा नहीं करना पेपर में कि लास्ट में राउंड ऑफ कर दो. That will be wrong because when a computer will do the calculation, the computer will do the rounding at each and every step when it will be executed. अगर उनको उसको 11.01 का स्क्वायर निकालना है, that is not fit, वो कैसे करेगा? -11.01 into -11.01, it will be multiplied and only the 4 digits can be stored, right? So when you will do this, this is -11.01. This is coming out to be your 121.2201. I'm just writing the full first, and this is coming out to be your -0.0507012, right? So now you have to do only 4 digit rounding. इसका मतलब इसमें टोटल डिजिट्स कितनी होनी चाहिए? 4. यहाँ पे कितनी है? More than 4. So that means when you will do the rounding, you will left only with these digits 1 to 1.2. Is it clear? Yes or no? Again, when you do 4 into AC, you have to do only 4 digit rounding. You can have 1, 2, 3, 4. This will be deleted, and this I have done rounding because the digits at n plus 1th place that are less than 5, right? So this is sorry. So this is coming out to be your 2.004. ठीक है? Next step, when you have -11.01, when you will do its subtraction, right? It is coming out to be your 1 to 1.1493, right? And this is the same 2.004. Now what will happen? When you have to do the rounding at this step, what will happen to this case? You can have only 4 digits. That is 1, 2, I am actually doing all the steps simultaneously, but when you will store it in computer, it will do the step by step, right? आप इसको नहीं करो, ये बाद में कर लेना rounding. You can do it later, right? You just write it here 2 into 1.002. Right? And this you can also write कि पहले आपने 11.01 स्क्वायर की राउंडिंग हुई, फिर आपने 4 into a करा, उसकी राउंडिंग हुई, फिर जो आपका आंसर आया दोबारा राउंडिंग हुई. That what I am repeating again and again, that computer will do rounding at each every end step. That means when you will calculate 4 into a into c, पहले वो 4 into a करेगा, it will use the rounding of 4 digit. The approximated answer will be multiplied by c, right? Then it will do the rounding for 4 digit. b square उसने निकाला, it is multiply b into b. That means the rounding will be done at this step also, right? That just for the time limitation I am writing this in the simultaneous step, but the computer will do the rounding at each and every step. And whenever you will do calculation, for every calculation it will use rounding arithmetic, whatever you are using, right? So now you can see from here that you have, when you are doing the subtraction, it has 4 significant digits. It also has 4 significant digits, but when you have subtracted, you can consider only 4 digits. That means this number will be rounded off to 1 to 1.1. That can have only 4 digits, right? So in denominator, when you will multiply 2 into 1.002, in the end you will have 4 digits, right? So that means this is my -11.01 plus minus इसका राउंड स्क्वायर रूट निकालोगे, that you will come out to be your 11.0045, right? So when you will do the rounding, क्या होगा इस स्टेप में भी? सिग्निफिकेंट डिजिट्स ही चाहिए ना, because it has written 4 digit arithmetic. It has not written 4 decimal arithmetic. So you can have total only your 4 digits. So इसमें digits आपकी कितनी रह जाएंगी सिर्फ? That is your 11.00, 2.004. Just I am ending this, then we will continue in next. यहाँ से निकालो x1 for the operation minus 11.01 plus 11.00. That when you will do its subtraction, this is minus 0.01 and you have 2.004. So this is coming out to be your 0.00499,002. Using 4-digit arithmetic. Okay. So you can see आपका x1 आ क्या रहा था? But you got the value of x1, that is coming out to be your minus 0.0011. इसका मतलब जो आपने आंसर निकाला है 4 digit से, that means you have lost your accuracy, because there you got the difference of two very close number. You can see here minus 11.01 and 11.00, both are very close number. That's why you have lost your accuracy here. And you can see कि ये आपका जो आंसर है वो कहीं भी उसके पास भी नहीं है, and it does not satisfy the equation as well. Minus also sign, right? Okay, thank you.